Sometimes we're asked to work out the area underneath a curve, and it's not actually possible to integrate the equation. So when we have this situation, we can get an approximate answer by using the Trapezium Rule. So this will only give an approximate answer. The technique for this is to split up the area that we're trying to find into a number of different trapezia, all with the same height, although in this case it's going to look like a width. So each of these is going to be, we're going to call it h, so it's h from there to there, it's h from there to there, and so on. Each of these is h. And what we're going to do is we're going to work out the area of each of these trapezia and then add them together. Now let's suppose that we know that the heights of the graph at these points are, let's say, y0, y1, y2, y3, y4 and y5. So to work out the area, we can say that it's approximately equal to, well, firstly we'll do the area of this trapezium. Now the area of a trapezium is that height, or that length there, plus that length, divided by 2 times by the width or the height, depending on whether you want to call that a width or a height. So it's going to be a half h y0 plus y1. The same is true for this trapezium. It's going to be a half of those two sides, that side and that side. Add them up, divide by 2 times by h. So we get this expression here. We've got 1, 2, 3, 4, 5 trapezia, 1, 2, 3, 4, 5 expressions. Now we're going to simplify this whole expression. If you look carefully, there's a half in every term. There's also an h in every term. So a half h is a factor. What's left? Well, there's y0, and then there's y1 and another y1. And then there's y2 and another y2, and y3 and another y3, y4 and another y4. And then finally there's a y5. Now I split up this shape into 1, 2, 3, 4, 5 trapezia. You don't have to split it up into 5. The greater the number of trapezia that you split it up into, the greater the accuracy. So what we want is a formula that's going to reflect the fact we can split it up into any number of trapezia. It is only an approximation, and let's just take one of these trapezia and then just enlarge it slightly. What we've got is we're trying to find that area, and we're saying that it's approximately equal to the area of that trapezium with a straight edge. So that is why it's only approximate. So the smaller this h here, and the more trapezia that we use, the greater the accuracy. But obviously the more of these we use, the more working out there is to do. So to sum up, we get this formula here. We just had the first y number and the last y number, they just occurred once, and then the y1, y2 and everything else occurred twice because they were at the ends of 2 trapezia each time. H was the gap. Now this next bit is dangerous because there is a formula which says h equals b minus a over n, but really my advice is not to use that, but to use your common sense. You'll see that when we do the example. So here's an example of how to use the Trapezium Rule, and we're going to have to work out different values of x and y. So to do that we need a table. The first value of x is 0, the last value of x is 2. We need to be careful about 4 strips. 4 strips means there's going to be 4 trapezia. So the first one's going to be between 0 and something. That's the first one. The second one is going to be between that and something else. That's the second one. So that's the first, the second, the third, the fourth. So there's 1, 2, 3, 4. So that is now the right number of x numbers to fill in. The x numbers go up by equal amounts each time. This is what h is, and it should be a bit obvious that that number there is 1, this number is a half, and this number is 1.5. Now I've got to take the equation and work out the y numbers for each of these different x numbers. When x is 0, 2x is 0, so it's the square root of 3, which is 1.732. When x is a half, 2 times a half is 1, 1 plus 3 is 4, the square root of 4 is 2. When x equals 1, 2 times 1 is 2, add 3 is 5, it's the square root of 5, that's 2.236. When x equals 1.5, 2 times 1.5 is 3, 3 plus 3 is 6, and the square root of 6 is 2.449. And then when x equals 2, 2 times 2 is 4, 4 plus 3 is 7, the square root of 7 is 2.646. I haven't left enough room there. If there weren't technical problems, I'd rub out that line here and make it down there, but I can't do that. Okay, so the area is approximately equal to, and what's the rule? Well, it's a half of h. What's h? H is the number by which x increases each time. So it's a bit obvious that h is a half. So that's a half times a half. And then what's the formula? It's the first term and it's the last term. So that's 1.732 plus 2.646, and then it's 2 times all the other terms added up. So it's 2 times 2 plus 2.236 plus 2.449. So that's a half times a half, which is a quarter, and then we need to work out the rest. Now it's always very important that you show you're working, so let's do this a step at a time. So that's 4.378 plus 2 times 6.685. So that's 1/4 of, so that's a quarter times 17.748, which is 4.44 to 3 sig figs.